We are starting a unit on probability. Today we're going to look at experimental and theoretical probability. There's a lot of vocabulary, so some of it is listed here. An outcome is our first term, and that's the possible result of a situation or experiment. So if I'm pitching a ball, the outcomes that are possible are a strike or a ball. The event, an event is a single outcome or a group of outcomes. So I can look at one pitch, or I can look at a game of pitching. The sample space is all of the possible outcomes. So in this case, it would be a ball or a strike. Probability is the measure of how likely it is that some event occurred. So what's the chance that I pitched a ball or I pitched a strike? Experimental probability is based on repeated trials of an experiment written as a ratio. So if I was looking at an actual game and keeping the stats from that game, I could use that information it would be considered theoretical probability because it's looking at a live event and writing out how many times I was successful doing a strike over how many times I actually threw a pitch. That would be experimental probability. Theoretical probability is the mathematical estimate of that. So since I can only pitch a ball or a strike, the theoretical probability of pitching one or the other is 1/2, 1 out of 2. Complement of the event is everything that's not the event. So if the event I'm looking for is pitching a strike, not the event is pitching a ball. So the probability of the two events have to add, the probability of the event and not the event add to 1. A tree diagram is a graphical way to show all the possible outcomes in a situation or experiment. We're going to look at a couple of those. A frequency table shows the frequency of data from a survey or experiment according to 2 categories. The rows show one category and the columns show another. We're going to look at one of those. And then we're going to look at relative frequency, which is the frequency of a category or an event over the total frequency, which is very much the same idea as probability, right? How many times it happened over all the total times that could have happened. All right. So looking first at our first tree diagram, Jane wants ice cream. The ice cream shop has this tree diagram in the window. Probably not, but we're going to use that idea. And these are all the possible ways that you can get your ice cream. You can either have a cup or a cone, you can either have vanilla or chocolate ice cream, and you can either have sprinkles, nuts, or strawberries on the top. Not any combination of those 3, just one of those 3. So then we're going to look at the possible outcomes. Well, remember, outcomes are all the possible results of a situation or experiment. Okay? So in this case, I'm going to have a cone and vanilla and sprinkles, a cone of vanilla and nuts, a cone, vanilla, strawberry, or I can do a cone with chocolate ice cream, sprinkles, cone with chocolate ice cream, nuts, cone with chocolate ice cream, strawberries. Are you getting the idea? So these are going to be this whole tree, the whole branch, all to the end is the actual outcome. But I can just count the ends of the branches to figure out what the total outcomes are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 outcomes. So there's 12 possible outcomes. This is considered my sample space, all of the possible outcomes, okay? How many combinations would there be if the ice cream shop added another flavor? So let's say they add strawberry. All right. Well, I can either have strawberry on a cone with sprinkles, nuts, and strawberries, or I can have strawberries in a cup with sprinkled nuts and strawberries. So that's going to give me 3 more options with the cone and 3 more options with the cup. So 3 more plus the 12 I already have would give me 18 possible combinations. How many combinations can Jan get with vanilla ice cream? Well, she can get a cone, vanilla ice cream, and 1, 2, 3 toppings, so that's 3. Or she can get a cup and vanilla ice cream and those 3 toppings, so she can get a total of 6 vanilla choices. How many combinations can she get if the ice cream shop runs out of nuts? Okay, well, if we run out of nuts, then she can't have this one, this one, this one, or that one, which eliminates 8 from my 12. So now I have a total of 8. It eliminates 4 from my 12, which gives me 8. How many combinations can she get with chocolate and strawberries? Well, here's chocolate and strawberries, and here's chocolate and strawberries, so she can get 2. Okay, so that's how you would use a tree diagram to figure out the outcomes. This whole thing, again, is the sample space, right? I can get cone, vanilla, sprinkle, cone, vanilla, nut, cone, vanilla, nut, strawberries. Those are the outcomes, the combination of all three things. All right. Now we're going to look at a spinner. A spinner has 3 equal sections, colored red, blue, and green. A student conducts an experiment where she spins the spinner twice and records the results. So she spins it, gets a result, spins it again, gets a second result. The results are shown in the frequency table below. So what's the probability that she's going to get red exactly once on the next 2 spins? So when I look at that, I have to look at all the times she can get red once. She can get red once here, 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 here. Yes? 1, 2, 3, 4. Okay. And I have to look at the total number of times that it happened. So 3 and 5 is 8, so I'm going to add all these up, 10, and there's a total of 23. So what's the probability of spinning red exactly 1 time in the next 2 spins? Well, let's see, there were 5 here, 5, 6, 7, 11, 13. So she has 13 out of 23 chances of spinning exactly red 1 time in the next 2 spins. What's the probability of spinning blue twice? That means it's going to be blue then blue. Well, that's this, so she's got a 1 in 23 chance of that happening because that's the only place it happens, the blue and blue. Okay, and remember this is experimental probability. This is a frequency table showing me what happened during the experiment. Okay, now we're going to look at some theoretical probability. Theoretical probability says, well, what are the possible things that could happen? So if I flip a coin and I flip it twice, I can get heads the first time and heads the second time. But then I could also flip it and get heads the first time and tails the second time. Or I could flip it and get tails and then heads. Or I can flip it and get tails and then flip it again and get tails. Those are my possible outcomes. Okay, if I was looking at a tree diagram, I would do, my first branch would be heads and tails, and then from each one of those, because I have a second flip, it would be heads and tails, because that's what I can get for the second time around. Notice that there are 4 outcomes, and there are 4 outcomes. To abbreviate them, it's head, head, heads, tails, tails, heads, tails, tails. And these are tails, heads, tails, and tails, heads are different, even though it's the same 2 letters, because this order matters. What order I did it in mattered. Okay. With that information, what's the probability of getting tails on both flips? That's this one right here. It's 1 out of 4 chances. So my probability of getting tails twice is 1 in 4. What's the probability of getting at least 1 tail? Well, that happens 3 times. 1, 2, 3. That is all the total, which is 4. So that's 3/4. The complement of that would be getting no tails, which is this one, right? So the probability of no tails, or probability of flipping heads, is 1/4, right? Because it only happens 1 out of 4 times. And 1/4 and 1/3 add together to give you a total of 1, which is what what we know, is the complements will add together to get 1. Okay, last thing we're going to look at. A student records the favorite season for 50 students. The results are shown in the table at the right. So here's my response. What is the relative frequency of spring? Well, before I can figure any of that out, I need to know what the total is. So adding these together, I have 20, 39, 40, 50. So I had 50 students surveyed. Oh, it actually told me that. I had 50 students surveyed. So the relative frequency of spring was 13 out of 50. Remember, it's just the same ratio. It's the idea of probability. How many times did they answer that out of all the times they were asked? What's the relative frequency of winter? Well, they answered 7 times out of the 50 students asked. If the table included the number of responses for only 3 of the seasons, so let's say it only included these 3, could you figure out how many were supposed to be in the fall answer? Well, yes, you should be able to, because you would subtract these answers, and whatever's left out of the 50 is how many answered in fall. Okay, that's a quick look at theoretical and experimental probability. We'll talk about it in class.